Software is everywhere. It's in our phones, our cars, and even our toasters. From the moment we wake up to the time we go to bed, we interact with software in countless ways. It's in the alarm that wakes us up, the coffee machine that brews our morning cup, and the smart TV that entertains us in the evening. As software gets more complex, it's more likely to have bugs. These bugs can range from minor inconveniences to major issues that can disrupt our daily lives. The more features and functionalities a piece of software has, the more opportunities there are for something to go wrong. Bugs are errors in code that can cause software to crash or behave unexpectedly. They can be caused by anything from simple typos to complex logical errors. When a bug occurs, it can be frustrating for both the user and the developer. Complex software systems are like giant puzzles. Each piece of code must fit perfectly with the others to create a functioning whole. If even one piece is out of place, the entire system can fail. They are made up of millions of lines of code. Each line of code is a small part of a much larger picture. Writing and maintaining this code requires a high level of skill and attention to detail. These lines of code interact in complex ways. A change in one part of the code can have unexpected effects on other parts. This interconnectedness makes debugging a challenging task. Even small errors can cause big problems. A single misplaced character or incorrect variable can cause an entire application to crash. These small errors can be difficult to find and fix. Imagine a team of builders constructing a skyscraper. Each beam and bolt must be placed with precision. If even one beam is slightly off, the entire structure could be compromised. If even one beam is slightly off, the entire structure could be compromised. This is similar to how a small bug in software can cause major issues. That's what it's like debugging complex software. Developers must carefully examine each line of code to find and fix errors. This requires patience, skill, and a deep understanding of the software. Debugging is the process of finding and fixing these bugs. It involves identifying the source of the problem, understanding why it occurred, and implementing a solution. It can be a time-consuming and frustrating process. Developers often spend hours or even days tracking down a single bug. But despite the challenges, debugging is a crucial part of software development. Without it, our software would be unreliable and full of errors. Traditional debugging methods often feel like a game of cat and mouse. Developers use tools to step through code, line by line, trying to isolate the source of a bug. It's a slow and methodical process, often relying on intuition and experience. Imagine searching for a single misspelt word in a library full of books. That's the challenge developers face when debugging complex software. These traditional methods are often inefficient and error-prone, especially as software grows increasingly complex. It's like trying to find a needle in a haystack using only a magnifying glass. Developers need more powerful tools to help them find and fix bugs quickly and efficiently. Artificial intelligence, or AI, is rapidly changing the world around us. From self-driving cars to medical diagnosis, AI is being used to solve complex problems. AI is particularly well-suited to tackling the challenges of debugging. Think of AI as a superpowered detective for your code. AI can analyze vast amounts of data, identify patterns, and make predictions that are beyond human capabilities. AI tools can automate many of the tedious tasks associated with debugging. This frees up developers to focus on more creative and strategic work. Machine learning is a type of AI that allows computers to learn without being explicitly programmed. In the context of debugging, machine learning algorithms can be trained on massive data sets of code, learning to identify patterns and anomalies that indicate bugs. Imagine showing a machine learning algorithm thousands of pictures of cats and dogs. Eventually, it would be able to distinguish between the two with remarkable accuracy. Similarly, machine learning algorithms can be trained to recognize buggy code. These algorithms can analyze code in real time, flagging potential bugs as they are written. This is like having a spell checker for your code, catching errors before they can cause problems. Neural networks, mimicking the human brain to squash bugs. Neural networks are a type of machine learning inspired by the structure of the human brain. These networks consist of layers of interconnected nodes or neurons that process information in a way similar to our own neural pathways. By mimicking the brain's ability to learn and adapt, neural networks can tackle complex tasks that traditional algorithms struggle with. They excel at pattern recognition and can be trained to identify even the most subtle bugs in complex code. This is achieved through a process called training, where the network is exposed to vast amounts of data and learns to recognize patterns and anomalies. Over time, the network becomes proficient at spotting irregularities that could indicate bugs. Imagine a neural network trained on millions of lines of code from various projects. This extensive training allows the network to develop a deep understanding of coding practices and common pitfalls. It can then apply this knowledge to new code bases, identifying potential issues that a human might overlook. This network could identify patterns and anomalies that indicate potential bugs, even in unfamiliar code bases. By continuously learning from new data, the neural network can adapt to different coding styles and languages, making it a versatile tool for developers. Neural networks can learn from past debugging experiences, improving their accuracy over time. Each time the network encounters a new bug and learns how to fix it, this information is incorporated into its knowledge base. This means that the more the network is used, the better it becomes at identifying and fixing bugs. They can even predict the likelihood of a bug occurring based on various factors, such as the complexity of the code or the experience of the developer. By analyzing these factors, the neural network can provide developers with insights into potential problem areas, allowing them to proactively address issues before they become critical. AI in action. Real-world examples of AI-powered debugging. AI-powered debugging tools are already making a real-world impact. Companies like Google and Facebook are using AI to find and fix bugs in their massive code bases. For example, Google's ClusterFuzz project uses AI to automatically find and report bugs in the Chrome web browser. This has resulted in a significant reduction in the number of security vulnerabilities. Another example is Facebook's SapFix tool, which uses AI to not only identify bugs, but also suggest potential fixes. This significantly speeds up the debugging process and allows developers to focus on more challenging tasks. The benefits of AI-powered debugging: faster, smarter, and more efficient. The benefits of using AI in debugging are numerous. AI-powered tools can dramatically speed up the debugging process, freeing up developers to focus on building new features and improving software quality. Imagine finding and fixing bugs in a matter of hours instead of days or even weeks. That's the power of AI-powered debugging. AI-powered debugging tools can also help to improve the accuracy of bug detection, reducing the number of bugs that make it into production code. This leads to more stable and reliable software, which is essential in today's technology-driven world. The future of AI in debugging. A glimpse into the crystal ball. The future of AI in debugging is incredibly exciting. We are on the brink of a revolution that will transform the way we approach software development. Imagine a world where debugging is not a tedious, time-consuming task, but an automated, seamless process. This is the promise of AI in debugging. As AI technology continues to advance, we can expect to see even more powerful and sophisticated debugging tools. These tools will not only identify bugs with pinpoint accuracy, but also suggest optimal solutions, learning from past experiences and continuously improving their performance. The integration of machine learning algorithms will enable these tools to adapt to new coding environments and languages effortlessly. Imagine a world where AI can not only find and fix bugs, but also automatically write test cases. This would free up developers to focus on more creative and complex aspects of software development. The AI would handle the repetitive and mundane tasks, ensuring that the code is robust and reliable, and even generate new code based on high-level specifications. Developers could simply outline what they need, and the AI would take care of the rest, translating high-level ideas into functional code. This would drastically reduce development time and open up new possibilities for innovation. This would fundamentally change the way software is developed, making the process faster, more efficient, and more accessible. Teams could collaborate more effectively, leveraging AI to streamline workflows and enhance productivity. The barriers to entry for new developers would be lowered, fostering a more inclusive and diverse tech community. AI could also play a crucial role in ensuring software security. By continuously monitoring code for vulnerabilities, AI systems can provide real-time alerts and recommendations, helping developers to address potential issues before they become critical. By identifying and mitigating vulnerabilities early in the development process, AI can help to create more secure systems that are less susceptible to attacks. This proactive approach to security will be essential in an increasingly digital world where the stakes are higher than ever. The future of AI and debugging is not just about making software development easier, it's about creating a safer, more innovative, and more efficient technological landscape. Conclusion: embracing the AI revolution in software development. The use of AI in debugging is revolutionizing the way software is developed. By automating tedious tasks, improving accuracy, and freeing up developers to focus on more creative work, AI is poised to transform the software development landscape. As we move towards a future increasingly reliant on complex software systems, embracing the power of AI in debugging will be crucial for building robust, reliable, and secure software that meets the demands of our ever-changing world. The future of software development is inextricably linked to the advancement of AI. If you learned something new, like the video, share your thoughts in comment section, and don't forget to subscribe the channel for more related videos.